We mentioned that in geometry, you work with shapes a lot. And starting today now, we're going to look at the most basic elements of geometry. The first one is what we call a point. Now, it's impossible for me to draw a point for you. A point looks like that, okay? But already that's not just one point, because if I were to zoom in on that dot, it would be a whole bunch of points. When you think of a point, you want to think of it as being infinitely small, just one small, tiny little location, and not a big old set of points. So a point is just a single, small, infinitely small dot, okay? And we'll usually give our points names, like we might call this point, point A, okay? The second one is what we call a line. And now we have the same problem. A line goes forever in one direction and forever in another direction, but it's infinitely skinny. You want to think of a line as consisting of a whole bunch of points that are all lined up. And since those points have no width to them, a line has no width to it. I have to draw it with some width to it so that you can see it on the board, but in your mind I want you to think of something very, very thin, that's so thin that it has absolutely no width at all. But I'll try to remember to always put arrows on the ends of my lines to help you remember that they do go forever in that direction and forever in that direction. Even though I stopped drawing it here, this arrow is telling you that it keeps on going. Now, if I draw a segment is just a portion of a line. It starts at one point and ends at another point. Okay? It doesn't keep on going. It starts and ends, and that's what we call a line segment. Now, just like we give our points names, we usually give our lines and our segments names. If this were point P on the line, and if this were point Q on the line, then we would call that line PQ. And there's the symbol that we use for that line that goes through those 2 points. Notice the arrows on either end. But if this is point F, and if this is point G, the segment started at F and ended at G, so here would be the notation for segment FG. Notice no arrows on either end. Okay? It starts at F, it ends at G. So a segment is not the same thing as a line. A segment is just a portion of a line. Now we also have what we call a ray. An array starts at one point and then goes infinitely far in one direction. So it's kind of like half of a line. If this were point R, and if this were point S, then I would want to say that this ray has its end point at R and goes in the S direction. So this is the notation I would use. Okay? Notice I've got a arrow on the S end, but I do not have an arrow on the R end. So this tells me that R is the end point, but it goes in the S direction. So that's what we call a ray. And notice that if I had one ray going this direction and another ray going in that direction, then stick those 2 rays together, you've got a whole line. And we have a name for that. Those are called opposite rays. Okay? One of them starts at point X and goes in the Z direction. The other one starts at point X and goes in the T direction. Ray XZ and ray XT are opposite rays. They both have their end point at x, but one of them goes in the z direction and the other one goes in the t direction. Okay? So those are the objects and their notation that we know about so far. Now I mentioned that we're going to be working with three-dimensional objects. And if you take, for example, a tissue box and look at the top of that tissue box top is a portion of what we call a plane. Again, I can't draw a plane very well because it goes infinitely in that direction, infinitely in that direction, infinitely in that direction, infinitely in that direction. It's like a big, big floor that goes forever in all those directions, but it has no thickness whatsoever. Okay? Again, I had to show it having a little bit of thickness so that you could see it, but the ceiling of this room, the floor of this room, the walls of this room are portions of planes, but they are only portions because these planes go forever in 4 different directions. Okay? So that's what we call a plane. Now, in geometry, we try to prove as much as we can. You'll get more familiar with what I mean by proofs later on in the course. But it's impossible to prove everything. We always have to have a starting place. Some things that we just assume are true. Things that are just obviously true. And we call these things postulates. And in this particular lesson, I'm going to show you 4 postulates. And here is the first one. Through any 2 points, there is one and only one line. Now that should be a pretty obvious thing, that if I have 2 points, then there's exactly one line that goes through those 2 points. Okay? I'm not going to ever prove that to you. That is something that's so obvious that we just call it a postulate and we just assume that it's true. I can't imagine 2 different lines going through those same 2 points. Now you might be thinking, well, what about something like this? Is that 2 lines going through the same point? And my beginning talk about what a line is, I may not have said it, but I should have said that these things are infinitely thin, but perfectly straight. A line has no curvature at all to it. So this one is trying to depict a line, but this one that has that curvature to it, that's not a line. There's only one line that goes through any 2 points. Okay? Our second postulate, postulate number 2, says that if 2 different lines intersect, they intersect in exactly 1 point. If I have a line like this and a line like this, you see that right there is their intersection, and their intersection is exactly 1 point. How else could 2 lines intersect other than in 1 point? Okay, a pretty obvious statement. Our third postulate, if 2 different planes intersect, their intersection is exactly 1 line. Think of the room that you're in. Think of the wall on this side and the wall in front of you. And those 2 walls come together right in the corner. And that corner is the intersection of those 2 planes. When 2 planes intersect, they intersect in a line. Now I'd like to try to draw that for you. In perspective, here is one plane. And now I'm going to try to draw another plane intersecting this one. Like so. Okay? We've got this plane that's laying down, and we've got this plane that's kind of standing up. And their intersection, the points that are on both planes, consists of this whole line of points. Okay? Now don't forget, the planes go forever, so the line of intersection goes forever. And then finally, postulate 4 says, through any three non-collinear points, there's exactly one plane. What's this non-collinear? If three points all lie in the same line, the prefix co means same. So those are 3 points that are collinear, same line. But if I have a point like this, and a point like this, and a point like this, those 3 points are not collinear, and this postulate says there's exactly one plane that contains those 3 points, namely the plane of this board. If I take the ends of my 3 fingers here, here's a point, here's a point, here's a point, 3 non-collinear points, you can imagine a plane that contains all 3 of those points. Now that wouldn't be true for 4 points. As a matter of fact, you've probably had the experience of sitting at a table where one leg is a little bit shorter than the other, and that table rocks. That's because you've got 4 points, and there is not a plane that contains all 4 of those points. That's why the table rocks back and forth. One plane, another plane, one plane, another plane. But if you had a 3-legged table, no matter how short one of those legs is, you'll always not have any rocking to it because there will be a plane going through those 3 points. So there's an introduction to our basic elements of geometry. Point, line, plane, segment, ray, and these 4 postulates that kind of describe how these things interact with each other.